Welcome to Jntu Technologies. In this present video, we will learn how to operate this obstacle sensor, the HCSR04 ultrasonic sensor with Nodemcu. So we are going to detect the distance by using this ultrasonic sensor. We'll put some hand or some object in front of it, and whenever the distance is detected, it gets displayed on the LCD. And whenever the distance is less than a threshold value, in our case we are putting 20 centimeter. So whenever the object is in front of it at a distance less than 20 centimeter, it will give you an LED signal. So if at all obstacle is detected, the LED will glow, and when you remove the hand, automatically the LED will be turned off. So in order to do this experiment, first of all, you need to change the jumper caps. Earlier we have used it for RFID. Now please make sure that this ultrasonic sensor has the two pins, that is trigger and echo. So you can see the pins D5 as well as D6. D6 is echo. So both clips are towards the upper side. So remove the jumper cap and put it on the top. So when you upload it, when you put the jumper caps on the top, and not only that, please make sure that the LEDs, that is L1 as well as the D4 L2 are connected on the top side. So whenever an obstacle is detected, you can see already I have uploaded the code. I have put my finger here. You can see I am putting my hand here and the red LED is glowing. So whenever I remove my hand, the LED is turning off, right? And normally it is printing the distance. Actually the distance, you see, I'm putting my camera, that's why it is showing the obstacle. The distance keeps on increasing. So whenever a distance of less than 20 centimeters detected, you see it is showing obstacle detected at so and so centimeter, right? How to do this? There are no libraries required for this. You just follow the jumper caps, whatever we have explained you here. So only 4 pins on the Nodemcu are used for this particular combination, and LCD is anyway connected to D1 and D2. Now we upload the code, and we upload the code. Just a minute. How to get the code? Well, the code is given in the folder supplied to you as program number 9. So in the code, in the folder supplied to you, you can see program 8 is RFID with LCD, the previous one. Program 9 is ultrasonic obstacle sensor. Just if you click on it, you will find one more folder. There you have the sketch, ultrasonic LCD.obstacle. Just double click on it, you will open this particular code. So here we are using trigger pin and echo pin as D5 and D6. Well, if you want to change the pins, you can change it, but accordingly you should keep the jumper caps over there. As jumper caps are not possible for all the pins, we can use female cables, female to female jumper cables, which are supplied to you. If at all you want to change on a different pin, right, you can try with that. For RFID it's not possible. For these sensors you can even change the pins, right? And similarly I2C LCD we have 27 16/2, and remember this is D1 and D2 reserved. You cannot use any other pin for controlling the LCD. So I have set the minimum distance as 15. I said wrongly, sorry. Earlier I said 20 centimeter. No, in the code it is 15 centimeter only. So any object in front of it for less than 15 centimeter, it will give you a warning by glowing the LED, also by printing the distance. So serial communication, trigger pin output, echo pin input, and D4 also output. We have used the D4 LED, that is the LED here L2. L2 means the second LED. Only that one we have used. The other one we haven't used. So only one, though I have set the pins towards the LED side, I am using only one. And LCD begin backlight, and then in this program we have first set the trigger pin for 2 microseconds high. It's low, and then we have set it for 10 microseconds high, and then once again pulled it back to low. This is the trigger which triggers the ultrasonic pulses. And then we have measured the duration from the echo pin. So for whatever time it remains in high position, the time duration is returned by this function in microseconds. So we know the distance formula, S equal to Vt, distance equal to velocity into time. So as we know, the velocity of sound is 340 meter per second. So by using that, we have converted this formula and finally obtained the distance. As the ultrasound starts from here, reaches the obstacle and bounces back, it is going to travel double to the distance. So if you call the distance as d, so it is traveling for 2d with a velocity v and a time of t in microseconds. So after conversion, we get this as that 0.0034 by 2, and this is going to give us the distance in centimeters directly. So we are putting the condition here. If the distance is greater than minimum distance, the minimum distance which I have put here is 15. So if it is greater than 15, it just prints LCD with the distance value in centimeter, and the pin will be low. The LED won't glow if at all it is beyond a certain distance, and same thing is printed in the serial monitor also. Or if it fails, if the distance is less than minimum distance, so if at all it goes below 15 centimeter, then LCD is going to get cleared, cursor is going to be set at first position, and obstacle detected is printed in the first line, whereas in the second line it is going to print at and the distance, at what distance the obstacle is detected, that is going to be printed. And also it is going to simultaneously glow this LED pin also, the light will be on, and same thing will be represented in the serial monitor, and it does this for every 1 second, right? This is what we are going to get whenever we cover here. I think you can see obstacle at so and so centimeter. When I am waving my hand, it is showing variable distances. Thank you.